Okay, so let's answer number 4. So sabi dito, picture frame hung against a wall, suspended by 2 wires attached to its upper corners. If the 2 wires make the same angle with the horizontal, what must this angle be if the tension in each wire is equal to 0.75 of the weight of the frame? So halimbawa, meron tayong picture frame and then it hangs against a wall suspended by 2 wires attached to its upper corners. Yan. And the 2 wires make the same angle with the horizontal. So, ibig sabihin, pag ganyan yung kanyang wire, and they both make the same angle with the horizontal dito. What must this angle be if the tension in each wire is equal to 0.75 of the weight of the frame? So, first, let's draw the FBD of the frame. And so, meron tayong weight niya, no? Weight ng frame natin. And then we have, let's call this rope 1 and let's call this rope 2. So, rope 1 is hinihila niya yung frame pa ganyan. And rope 2, hinihila niya yung frame sa kabila naman. Okay, so you have T1 here and T2 here. Okay, and they make the same angle with the horizontal. So, ito yung angle na yan. So, that's basically this one. Okay, yan yung angle na tinutukoy natin. Now, yung T1 and T2 daw natin ay parehong 0.75 of the weight of the frame. So, which means that T1 is equal to T2 is equal to 0.75 the weight. So, after natin ma-determine yung FBD natin, the next step is to identify if the system is accelerating. So, obviously, the system is at rest. So, the net force is just 0. So, next na ay yung summation of forces. No? So, drawing ko lang na ito yung ating y-axis. And ito naman yung ating x-axis. So, summation of forces tayo. Summation of force along x and summation of force along y. So, yung forces natin along x, kung titignan nyo, ang direct lang na nakikita natin ay si weight, nasa y. Pero yung T1 tsaka T2 natin ay may component along x and y. So, kung lalagyan natin yung drawing natin, ito si T2 and ito si T1. No? And meron na naman tayo dito yung theta, ito rin yung isang theta. Meron tayo dito T2x at meron tayo dito T2y. Ganon din dito. You have T1x and you have T1y and you have the weight here. Okay, so sa x natin, ang forces natin ay basically sina T1x lang at saka si T2x. So I have negative T1x plus T2x is equal to 0. Now, para sa weight na para sa y naman natin, meron tayong T1y, T2y, and weight. So, you have T1y plus T2y plus negative weight is equal to 0. So, ang alam lang natin, itong T1, T2 is 0.75 ng weight. Wala siyang ibang binigay na values. No? So, the next thing that we need to do, pag na-recognize nyo na itong x and y are basically components, so pag may components, kailangan ulit mag-sine at cosine, yun yung gagawin natin dito, no? So, kay T1, ito yung itsura niya. Theta, T1, T1y, T1x, no? So, ang T1x natin is adjacent, so you simply have T1 cosine theta, and yung Ty natin ay opposite, so this is simply T1 sine theta. So, kapag ganito, mas madaling gamitin yung method 1, no? So, doon sa vectors natin before, yung method 2, where this time, yung method 1 naman. So, yung T2 naman tayo, sa T2 naman tayo, T2 and theta. So again, T2x is again T1, T2 cos theta. And itong T2y natin is again T2 sin theta. Okay? So I'm going to rewrite this equation. Palitan ko na to at tanggalin ko na to since na ayos naman na natin. So we simply have negative T1 cosine theta is equal to, tanggalin ko na yung negative kasi parang ililipat mo lang siya dito. So T1 cosine theta is equal to T2 cosine theta. Wala tayong masyadong makuha, diba? Kasi parang sinasabi nyo lang, T1 x is equal to T2x. Eh, alam natin na parehas naman tong value na to. So, kumbaga parang pwede mo siya i-cancel, pwede mo siya i-cancel. So, wala, diba? Now, let's proceed to y. Sa y natin, meron tayong T1 sin theta plus T2 sin theta. Parehas na plus to plus kasi parehas silang pointing upwards, no? T1y and T2y is equal to weight. No? So, nilipat natin si weight sa kabila. Ngayon, alam natin na si T1 at T2 equal lang. And yung value nila is 0.75. So, kumbaga, parang pwede natin itong isulat as 2T sin theta is equal to weight. And yung T, alam natin as 0.75. So, meron kang 2 times 0.75 weight is sin theta is equal to weight. So, meron tayong sin theta is equal to weight over 2 times 0.75 weight. So, cancel. We get theta is sine inverse. Na mag-arc sine tayo. Sine inverse ng 1 over 2 times 0.75. So, this gives us theta is equal to 41.8 degrees. Okay. So, itong angle na to is 41.8 degrees. Okay, let's go to example number 5. For some classes, I've already solved this one, pero for some, hindi pa, no? So, for number 5, sabi dito, a man pushes on a piano with mass 180 kilograms so that it slides at a constant velocity down a ramp that is inclined at 11 degrees above the horizontal. Neglect any friction acting on the piano. Calculate the magnitude of the force applied by the man if he pushes parallel to the incline, and what will be the magnitude if he pushes parallel to the floor. Okay? So, ang mangyayari, ito yung ramp natin. Letter A muna tayo, no? Pushes parallel to the incline. So, ganyan. So, say for example, nandito yung piano. And, yung nangyari kasi dito, nung in-assume ko na pinupush down niya yung piano, nag-negative yung sagot. So, let's try to assume na habang nagsislide yung piano, pinupush niya at nasa baba siya. So, parang kumbaga, nandito yung man, tas nandito yung piano, pinupush niya yung piano habang bumababa yung piano. Parang ganun. So, okay. So, gawan natin ng FBD. So, obviously, meron tayong normal, perpendicular ulit. And then you have the weight. Okay? And then, yung assumption natin is, yung push is pa ganyan. Kasi kapag pabaliktad, nagiging mali siya, nagiging negative. So, F applied is to the other side. Okay? So, gano'n na naman, meron na naman tayong tilting. And sabi natin, kapag ganito, hahanapin natin kung ano yung makikita nating perpendicular. In this case, perpendicular si normal kay F applied, and at the same time, perpendicular si normal kay surface. So, ibig sabihin, pwede kong iset itong si normal as my y-axis, and isa-set ko yung surface as my x-axis. So, kung ito-drawing natin to sa maayos na paraan, yung normal na untilted rampa untilted Cartesian plane natin. So, yung magiging itsura niya ay ganito. You have the normal here. Okay. And then, yung F applied mo pa left. And then, yung weight natin ay papunta dito. Okay. Weight. So, ito is 11 degrees. If this is 11, then this is 90. Then this must be 79 ba? Okay. This must be 79. So, itong part na to, this is 79. And this must be 11. Para 79 plus 11 gives you 90. So, this must be 11. And then, kung papansin niyo ulit, yung weight natin ay wala na naman sa eksaktong x, walang sa eksaktong y. So, ibig sabihin na naman yan, meron na naman tayong component sa x, ito yun, wx, at component sa y, wy. So, kung isusulat ko dito, parang meron tayong, wait, let me change the color. Meron tayong wy and wx. Okay, so yan yung ating complete FBD. Now, sabi dito, constant yung, tama ba? Constant yung speed. Wait. Ay. Makita. Okay, pero anyway, I think constant yung speed dito. So, ito na yung ating FBD. And since constant yung speed, ibig sabihin, the net force acting on the system is simply 0. So, tapos na tayo kay FBD, the next step is to write our summation of forces. Okay. So, summation of force along X and summation of force along Y. Yung X natin, meron tayo F applied, tsaka meron tayong WX. So, you have negative F applied plus positive WX, ay, ito pala siya vector, is equal to 0. Kasi non-accelerating. And then, yung Fy naman natin is normal and Wy. So, you have normal plus negative Wy is equal to 0. Now, ang hinahanap natin is magnitude of the force applied. So, hindi ko napapakialaman tong si y. Dito na lang ako magpo-focus kay x. So, ano si wx, no? So, kung i-drawing ko ng malaki itong triangle na to, then wx, wy, ito yung 11. So, si wx ay opposite, di ba? So, opposite siya. So, this is w sine theta. And then, ito naman ay W cosine theta. Again, class, for this method, it's easier to use, for this topic, it's easier to use your method 1, no, in vectors. Pwede pa rin naman yung method 2, no? So, measure from positive x-axis, pwede pa rin naman. Pero, mas madali yung method 1 kasi naka-triangle naman na. Makikita na natin agad, no? So, anyway, balik tayo. So, ito magiging F applied is equal to W sine theta. Okay, and F applied therefore is simply equal to mg sine theta, which is simply 180 kg times 9.8 meter per second squared times sine of 11. Okay, so hindi ko na papakialaman kung magpa-positive or negative pa kasi inallocate ko na lahat yun dun sa sign ng equation ko, yung summation of forces. 180 times 9.8 times sine 11. So this will give me F applied is 336.59. So this is 3.37 times 10 raised to 2 newtons to the negative x. Okay. Kayo na bahalang gumawa nitong second. What would be the magnitude of the force if he pushes parallel to the floor? Okay, so let me just guide you. So for the second one naman, ang nangyari, pushes parallel to the floor. So ito yung incline plane natin. Mangyayari dito, class, normal, weight, which is downward. Pero this time, hindi na magiging ganyan yung F applied. No, hindi na siya pa ganyan. Kasi ito, parallel yan sa incline. Ang mangyayari ngayon ay yung yung force applied ay parallel to the floor. So it's going to be like this. Okay, ito na yung F applied natin. So in this case, alin yung pipiliin yung X and Y axis? Kapag pinili natin di ba sabi ko ang hanapin nyo ay yung perpendicular, no? Saan may perpendicular? Although perpendicular si normal sa surface, may dalawa kang force na perpendicular din, that is your F applied and weight. So ibig sabihin, ang gagawin nyo pa rin na X and Y axis nyo ay ito, yung Y, at ito pa rin yung X. Okay, so ganyan siya. So, ang mangyayari, if this is 11, this is 90, ay, wait lang, wait. Okay. So, this is 11, this is 90, this must be 79, so, this must be 11, so figure out nyo na lang. And then, kayo bahala mag assess kung ano yung magiging angle kaya dito or angle dito. Okay? So, try to solve for this one for letter B. Let's go to number 6. A stockroom worker pushes a box with mass 11.2 kg on a horizontal surface with constant speed of 3.5 meter per second. The coefficient of kinetic friction between the box and the surface is 0.20. What horizontal force must the worker apply to maintain the motion? Okay, so meron kang surface, nandito yung box, and then, constant speed lang. So, non-accelerating ulit to. Meron kang normal, meron kang weight, meron kang F applied, ito yung pagtulak ng worker, and meron kang friction. Okay? So, this is a non-accelerating system kasi constant speed. So, net force is simply 0. Okay? Then next is we write down the summation of forces. Summation of force along X, summation of force along Y. Yung X natin is simply negative F plus F applied is equal to 0. And yung Y natin is simply positive N plus negative weight is equal to 0. Ngayon, yung ang hinahanap ko dito ay yung horizontal force that the worker needs to apply. No? So, basically yung F up. So, F applied is equal to friction. Pero walang binigay na friction dito. And kinetic friction to, no? So, Fk pala. So, walang binigay na friction sa atin. Therefore, we need to solve it. And if you remember, sabi natin nung nakaraan sa discussion, Fk is less than or equal to your mu Kn. Hindi naman natin pwedeng gamitin yung less than. So, we're going with the maximum, which is the equal. So, ito, F applied is equal to mu Kn. Okay? And then, alam natin si mu K, binigay siya. Pero yung N, kailangan natin isolve from the Fy. Okay? So, from Fy, N is simply equal to 8, meaning N is simply equal to mg, which is 11.2 times 9.8. So, kahit dito ko na solve. So, F applied therefore is simply equal to 0.20, yun yung mu K, times 11.2 times 9.8. Okay, so this will give us F applied is equal to 21.952, or F applied is basically 2.20 times 10 raised to 1 Newton to the positive direction. Okay. Next, let's go to example number 7. A worker applies constant. Ito, kaya nyo na ito, madali lang to. Skip ko na. Ito din, madali lang. Ito, we have already solved this in class, I think. Oh, for others, parang hindi. So, isolve natin. Example number 9. An elevator and its load have a combined mass of 800 kilograms. The elevator is initially moving downward at 10 meters per second as it slows to a stop with constant acceleration in a distance of 25 meters. What is the tension T in the supporting cable while the elevator is being brought to rest? So, gusto natin malaman yung tension T in the supporting cable daw. So, saan ba nag-act yung cable natin, di ba? Tension is exerted by the cable on the elevator. So, kung ito yung elevator natin, oops. So, gagawa na lang ng FBD elevator. So, kasi sabi niya, tension in the supporting cable while the elevator is being brought to rest. So, saan nag-exert yung cable? Doon kay elevator. Kaya FBD na elevator yung tinitignan natin. So, this is, oops. So, start tayo kay weight. And then this is tension. Okay? Now, it is important that you identify kung saan direction yung acceleration niya. Kasi obviously, the elevator is accelerating, di ba? So, it is moving downward at 10, tapos nag-slow to a stop. Ibig sabihin, it's moving to the negative direction and it is decreasing. So, bumababa siya and decreasing, meaning the acceleration is positive. Okay, so ito yung direction ng acceleration. Ito, balikan nyo na lang to sa kinematics natin. No? Ito yung parang binanggit ko dati na if the object is going to the positive direction and it is speeding up, then you have positive acceleration. Kaya din dito, it's going to the negative and it is decreasing. So, it's going to the, it has positive acceleration. Okay, so ito yung itsura ng ating FBD. Now, it is accelerating, yes. So, summation of force along y is MAY. So, sulat natin yung forces natin. Along x is 0, wala tayong force sa x. Along y naman is simply T plus negative weight is equal to MAY. So, we want to get a T. So, this is simply T is equal to weight plus MAY, wherein weight is simply mg plus MAY. And we can rewrite this as simply m times g plus ay. Now, class, huwag kayo mako-confuse ha. Yung g is yan yung 9.8 ninyo. Ginamit na natin yung g na term ngayon kasi pag ginamit natin yung ay, magkakalituan ka kung anong ay na tinutukoy kasi meron tayong extra ay dito which is due to the elevator itself, no? Okay, so solve natin itong ay na to. Paano natin siya solve? So, merong binigay sa atin dito na VO is negative 10 meter per second. Initial yun. And negative siya kasi downward. And then V final is 0 kasi stop. And then, binigyan din tayo ng displacement. No? Y is 25 meters. Pero dahil pababa siya, magiging negative. So, hanapin natin yung AY. And this will use your fourth equation ng kinematics, which is Vy squared equal to Voy squared plus 2ay y minus y naught. Okay, so Vy is 0, so lipat ko lang to. Negative Voy squared is equal to 2ay 1 minus y naught. Cancel yung y naught, 0 lang siya. So divide both sides by 2y. And I'm left with ay is equal to negative of negative 10 squared over 2 times negative 25, and this gives me positive 2 meter per second squared. Okay? So, ito yung parang checker nyo din kung tama ba yung direction ng AY ninyo. Kasi class, kapag mali ito, kunwari ginawa nyo siyang AY is negative kasi moving downwards, eh yung equation nyo magiging negative MAY, which is wrong, di ba? Mali siya. So, positive daw. So, alam na natin yung AY, so we can plug in 800 times 9.8 plus 2. So, okay. So this will give us 9440 newtons, where tension is equal to 9.44 times 10 raised to 3 pala. 3 newtons to the positive direction. Ito example number 6. Kayo na mag-solve nito, no? Number 6, number 10. Then ito, I think I was able to discuss this in all of my classes. I'm going to skip it. Let's go to example number 12. Okay, so number 12, sabi dito, a 15 kilogram load of brick hangs from one end of a rope that passes over a small frictionless pulley. A 28 kilogram counterweight is suspended from the other end of the rope. The system is released from rest. What is the magnitude of the acceleration of the load of bricks? Okay, so obviously dito mas mabigat yung counterweight natin kasi niakyat natin yung bricks. And the system started from rest. Oops. It is from rest. Parang sa atin, magnitude of the acceleration of the load of bricks. So, paano natin siya kukuhanin? Eh, walang binigay sa atin dito na kahit anong value. Mas lang yung binigay, no? So, mas lang yung binigay sa atin. So, ang gagawin natin is kailangan natin mag-drawing ng dalawang free body diagram. Okay, so before, shucks. Wait. Let me reset that again. Wait. Ayan, okay. Saglit. Okay, so, ang gagawin natin dito, dalawa yung object natin. Yung 28 kilogram and yung 15 kilogram object. But what we don't know about them is that they share the same group. No? So, ibig sabihin kung anong tension nito, tension din dito. So, magkaparehas lang. Okay? So, wala tayong bang given bukod sa mass. So, let's try to work around it. So, first, gawa tayo ng FBD ng bricks. So, yung bricks natin, may weight. So, weight of bricks. And then, meron siyang tension. Okay? Now, for the FBD of our counterweight, yun din, meron siyang weight, counterweight. So, B for bricks, CW for counterweight. And again, meron din siyang, oops. meron din siyang tension. Okay? Ngayon, yung brakes natin, obviously, nagtatanong siya ng acceleration. Di ba? So, ibig sabihin, nag-accelerate yung system natin. Now, we need to determine saang direction mag-accelerate yung system. So, si brakes natin, they both started from rest. And si brakes natin is from rest. Siyempre, mag-i-increase siya to the positive direction. So, meron siyang positive acceleration sa brakes. No? So, AY of brakes. Now, yung counterweight natin, nag-start din siya sa rest. Tapos, mag-i-speed up siya, pero to the negative direction. So, bibilis siya, pero sa negative direction. So, ang AY naman nito ay negative. Okay, baliktad. Okay, bibilis siya to the negative direction. Yung isa kanina, bibilis siya kasi from rest up to some speed to the positive naman, positive direction. So, ang mangyayari dito, itong EY natin, hindi natin alam. And syempre, kung ano acceleration ni brakes, acceleration din ni, hindi pala. Hindi pala sila magkaparehas ng acceleration. So, yung tension lang pala yung parehas. Okay, kasi magkaiba pala ng mass. So, mangyayari, plus, so, may sulat tayo ng FBD. So, summation of force along Y, P plus negative WB is equal to positive MAY B for brakes to. For counterweights naman, Fy is simply T plus negative weight of the counterweight equal to negative MAY of the counterweight. Okay, so ang alam natin, same yung tension nilang dalawa kasi nga they share the same rope. So, i-transpose ko to sa kabila. Transpose sa kabila. So, I have T is equal to MAY B plus weight of B. And then, yung isa naman is tension is equal to weight of the counterweight minus MAY of the counterweight. So, C na lang ilalagay ko no, per counterweight. Ngayon, pwede kong i-simplify itong T. No? So, T is equal to M. We need to remember pala before yan. Na M of brakes ito, M of counterweight ito. So, baka kasi magkahalo, no? So, ito pwede ko na isulat as T is equal to M of brakes times AY of brakes plus G kasi ang weight is mg. Tapos ito naman, pwede kong isulat as M of counterweight times G minus AY of counterweight. Oo, parang dapat kung ano acceleration nito, yun din yung tama class. Kung ano acceleration ng isa, yun din yung acceleration ng isa. Same lang pala. So, useless yung paglagay-lagay ko ng B. Tanggalin na natin. So, AY na lang to. So, same lang pala sila class kasi kung same yung tension nila, then same din yung acceleration nila kasi kung anong na-feel natin sa root, at kung gaano kabilis mag-accelerate to, di dapat ganun din to, no? So, yeah, they're the same. So, ibig sabihin, since equal yung tension na to, yung dalawang to, again sa counterweight to, counterweight. Ito naman ay sa brakes. So, since equal tong dalawang to, pwede ko silang i-equate. So, I have mass of brakes times AY plus G is equal to mass of the counterweight times G minus AY. So, this becomes MB times AY plus MB times G is equal to MC times G minus MC times AY. So, pwede kong pagsamahin lahat ng AY at pagsabahin lahat ng G. So, meron akong MB minus MC times G. So, lipat lang natin ito dito. Then, ito naman, lipat natin sa kabila. So, is equal to AY negative MB minus MC. Okay? So, MB minus MC is MB is 15 minus 28. So 15 minus 28 is negative 13 times 9.8 divided by divided by negative 15 minus 28, which is negative 43. So I have AY, which is 13 times 9.8 over 43. I get AY, which is 2.96 meter per second square to the positive direction. So yung acceleration ng bricks natin is 2.96 times 10 raised to 0 meter per second squared to the positive y direction. Okay, the next is, what is the tension in the rope while the load is moving? How does the tension compare to the weight of the load of the bricks and to the weight of the counterweight? So, dali na lang natin masosolve yung tension, no? So, we simply plug it in kahit saan. Pwede dito, pwede dito. So, to solve for the tension, tension is simply MB times AY plus G. So, I have 15 kg times 2.96 plus 9.8. This gives me tension 191.44. So this is simply 1.91 times 10 raised to 2 newtons to the positive direction. Okay. Now, may follow-up question siya na how does the tension compare kuno to the weight of the load of the bricks and to the weight of the counterweight? So, ibig sabihin, parang ano i-multiply mo sa tension para makuha yung weight? Or ano i-multiply mo sa weight para makuha yung tension? So, solve muna natin yung weight ng counterweight natin. So, this is simply 28 times 9.8. So, ang weight ng counterweight, kayo na bahala, mg lang to. So, this is 274.4 newtons. So, yung tension natin, or yung weight natin, para ano daw yung i-multiply mo sa tension natin para ma-compare mo siya kay counterweight. Kasi sabi niya, how does the tension compare to the weight? So, ratio yung hinahanap natin dito. So, we have this one, the weight of the counterweight divided by tension. Oops. So, weight of the counterweight divided by tension. This will give us 1.44. And kapag yung weight of the bricks naman, weight of the bricks is 15 times 9.8, that is 147 divided by tension. This will give us 0.77. Okay, so hindi ko sa scientific notation kayo na bahala. No? So, ibig sabihin class, yung tension relative to the weight of the load is only 0.77. You know? So, 0.77 times greater yung tension kaysa kay weight ng bricks. Doon naman sa counterweight, baliktad, no? Ay, baliktad. 0.77 times the 0.77 times the tension gives you the weight of the bricks. And dito naman, 1.44 times ng tension yung counterweight. Okay, so kumbaga, itong si tension times around 1.5 ni para makuha yung weight ni counterweight. Pero kay bricks, less than 1 yung ratio nila. Okay, so yun yung letter B. Okay, next. Let me just adjust the size again. Okay, so ito sa example number 13 natin, sabi niya, you are lowering two boxes, one on top of the other down the ramp by pulling on a rope parallel to the surface of the ramp. Both boxes move together at a speed of 15 cm. Excuse me. Coefficient of kinetic is 0.444. Coefficient of static is 0.800. What force do you need to exert to accomplish this? What are the magnitude and direction of friction force on the upper box? Okay. So, dito may dalawa kang box on top of a ramp. So, both boxes move at 15 down baba. So, V is 15 cm per second, constant. So, ang nangyayari class, dalawa yung object natin and ang hinahanap natin ay force. Saan ba directly connected yung force natin? So, kung titingnan ninyo, yung force natin, yung pag-pull ni person is directly, yung rope pala na pinapull ni person is directly connected to the larger box. So, start tayo sa FBD ng larger box. Okay? So, meron tayong ramp. And as usual, meron tayong meron tayong weight. Ay. Okay. And then, sabi niya dito, may pull, di ba? So, hinihila. So, may tension. And at the same time, meron tayong friction between the ramp and the lower box. No? Yung lower box yung mas malaki. So, kung pababa yung box natin, ibig sabihin yung friction ay on the opposite side. So, papunta dito. Okay? Wait lang, class. Let me just answer the point. Okay. Okay, sorry, balik tayo. So, meron tayong, delete ko lang to. Ayan, friction. And then, ito isang, yung block dito is tension. So, dalawa yung force natin na pataas, tension, tsaka friction. Tapos, ang hinahanap natin is what force do you need to accomplish this? Ang force na hinahanap nyo ay yung tension kasi yun nga yung pulling yun, di ba? So, pag sinolve natin to, ang mangyayari is meron tayong ilang forces? 1, 2, 3, 4 forces. No? So, again, pag ganito may ramp, hanapin nyo kung saan may perpendicular. So, perpendicular si normal sa surface niya. At the same time, perpendicular siya kay tension, tsaka kay friction. No? So, ang gagawin natin ay isa-set natin ay, okay. Isa-set natin na si normal ang nasa y-axis. And therefore, itong surface natin ang x-axis. Kasi hindi siya mukhang perpendicular, pero perpendicular siya dapat. Okay? So, ngayon, ito yung positive y, yung negative y, positive x, negative x. No? So, ganyan yung ating orientation. So, Pwede niyo siyang i-restructure dito. Okay. Pwede ko siyang i-drawing ulit dito. This is normal. And then this is tension. And then friction. And then this is weight. Okay, so ganyan yung itsura natin, no? Ay, itsura ng FBD natin. Ngayon, mapapansin nyo na naman dito mula sa napatayong part class na yung W nyo na naman, meron na naman siyang component. So, meron siyang WX at meron siyang WJ at WI or WJ and WX, WY. Okay? So, dito, ito yan. WI or WX and WY. Okay, and this is W. Okay, so now let's write the angle. No? Kasi again, ang goal natin kuhanin dito ay yung T. So, ay angle, the summation pala of forces. So, summation along X, meron tayong positive tension, positive friction. So, T plus F. And then, meron ka negative WX. Plus negative WX is equal to, it is accelerating ba or hindi? Hindi. Kasi sabi niya constant speed. So, this is equal to 0 lang. And then, sa summation of forces along Y naman, meron kang normal, tsaka meron kang WY. So, you simply have normal plus negative WY is equal to 0. So, dito pala sa may examples na to class, mula kay example 12, halo-halo na siya, no? Ay, di pala. Mula dito sa example 13, mix na siya ng law of inertia at law of equilibrium. Law of inertia at law of acceleration. So, ang hinahanap ko ay tension. So, kukunin ko siya mula kay X. No? Pero I need to recognize again na meron akong WX at WY dito. So, based on the triangle, ano ba itong angle na to? Hindi natin na-determine kanina. So, walang binigay na theta sa atin. Saan kaya natin kukuhanin yung theta? Now, you need to remember na binigay ito. Okay, binigay siya. So, yung length daw is 4.75 tsaka 3.50. So, pwede kong isolve tong theta na to by using tan theta is opposite over adjacent. Okay, which is simply 2.50 over 4.75. So, this will give you the theta that is simply tan inverse ng 2.5 over 4.75. This is theta is 27.759. Okay, so 27.759 or 27.8. So 27.8 ito. Kung 27.8 yan class, so tayo kumikita. Kung ito ay 27.8, ito ay 90, itong sa part na to, then ano ito, no? So, nangyari dyan, 90 minus 27.8. So, it means that this one, the weight kasi means ito 90, this one is 62.8, 62.2 pala. And so, for 62 ito, 90 again to, no? So, ito ay 27 ulit. Okay, 27.8 ulit. So, parang, ang nangyari class is, ayan, so 27, 90, hinanap natin to, then subtract. Kaya ito ay 27.8, and then ito yung 62.2. So, relative to the angle, WX is opposite, so this is W sine theta, and then ito ay W cosine theta. So, magkakaroon tayo ng, let's rewrite Fx. Fx is simply T, kasi si T minanap po, equal to, lipat natin to sa kabila, W sin theta, then lipat natin si friction sa kabila, minus friction. Okay, and then si y natin, we can have it as is muna. Then, kung titingnan nyo ulit class, walang binigay na friction, pero binigay niya sa atin yung, coefficient ng kinetic friction. And again, this will be mg sin theta minus mu k n. Okay, mu k n. So, yung n natin is hindi siya mg lang. Yung n natin is wy, which is w cosine theta. So, ibig sabihin dito, susulat natin siya as mg sin theta minus mu k times yung n natin, which is also mg cos theta. So, pwede kong i-pull out si mg. So, t is equal to mg sin theta minus mu k cos theta. Ngayon, anong mass yung gagamitin natin? Yung mass ba ng larger box o ng smaller box? Kailangan natin i-consider yung mass ng buong object. Yung mass ng buong object. Bakit? Kasi kung as a smaller box, nakapatong kay larger box. So, nadadamay siya doon sa force. No? So, ang mass na i-consider natin dito is 48 plus 32, that is 80. So, 80 times 9.8 times sine of 27.8 minus 0.444 times cos 27.8. Okay? So, P now is equal to so this will give me tension na 57.73. Okay? Or 5 point, tama ba yung sinusolve ko? So 5.77 times 10 newtons. So this is to the positive x direction. Okay, so 57.73. Paki-double check na lang din yung mga values no, na nilalagay ko. So next is punta naman tayo sa magnitude and direction ba ng friction force on the upper box. So tandaan natin na sa upper box, meron tayong static friction. Okay? Meron tayong static friction. So I'm going to erase everything. Proceed tayo sa upper box. No? So sa upper box natin, ang force na nag-a-act ay, so nandito yung ramp, diba? Pero sa upper box natin, meron ka lang weight. And yung normal again is pa ganyan. Okay? And then meron kang friction. So dito, ang hinahanap natin ay friction. And we need to take note na yung static friction natin is also affected by your weight. No? So, ang mangyayari dito is, again, ito yung x, ito yung y. Okay, so parang katulad lang din kanina. So, summation of force along along x pala. So, you have F, positive, no? Kasi this is the positive x, and this is the negative x. So, positive F, yung pagsiset ko pala ng positive, negative class. Ako lang yung naglalagay niyan. So, bahala kayo kung gusto nyo yung negative, ito yung positive. Okay lang, no problem. So, positive F plus negative W plus, kasi nga, ito, may wx ka na naman, and may wy ka na naman. Okay, so f plus negative wx is equal to 0. So you have f is basically equal to wx, no, which is simply, ang wx natin, ang w natin is mg sine theta. So this is simply mass, which is, wait. Sorry, meron na pala, I don't need to do this pala. Kasi, yes, I need to do this. Kasi pala, dito, ang ibibigay nyo lang sa akin is fs less than or equal to mu sn. So, range yung ibibigay nyo kasi kapag ito yung ginamit ko. So, I don't know the exact. So, to get the exact, ito yun. So, hindi ko na ibabalik. We simply plug in values. So, this is 32 times 9.8 sine of 27.8. Okay, so friction is equal to 32 times 9.8. Okay, so the friction force is 146.258. So this is simply 1.46 times 10 raised to 2 newtons. Parang weird. Wait, let me just check my notes. Okay, so I think it's the correct answer naman. Okay. So yung direction is also positive x direction, which is the same as the direction of our kinetic friction kanina. Okay, so let's proceed to example number 14. Again, let me just adjust the size of the image. Okay, so an inventor designs a pendulum clock using a bulb with mass M at the end of a figure of length L. Instead of swinging back and forth, the bulb is to move in a horizontal circle with constant speed with the wire. So, circle with constant speed. Okay, with wire making fixed angle beta with the vertical direction. This is called a conical pendulum because the suspending wire traces out a cone. No? So, kasi paikot na siyang ganyan. Find the tension F in the wire and the period T, which is the time for one revolution of the bulb. So, instead of using T for the tension here, F yung pinapagamit sa atin because we need to find the T period. Okay, so may highlight ako dito, which is horizontal with constant speed. Okay, ibig sabihin, ito ay isang uniform circular motion. Okay, so uniform circular motion siya. And ang sabi dito, ay pinapahanap sa tension tsaka period. Okay, so una, gawa muna tayo ng FBD na bulb kasi si bulb yung gumagalaw yung ito. Ito yung bulb, no? Yung bilog. So, FBD of the bulb. So, ayan siya. Meron siyang weight, diba? And at the same time, it is being pulled by a wire, no? So, habang umiikot siya, laging wire ay laging naka-angle with beta, no? Yung wire from the vertical. So, ganyan yung ating force, no, yung tension. And it has always an angle beta. Yung beta natin. Wait. So this is force and this is angle beta. Ngayon, there are no other forces acting on the system. So the next thing that we need to identify is nag-a-accelerate ba yung ating bulb. No? So kung tignan nyo, nag-accelerate ba siya? Ano sabi natin sa uniform circular motion? In uniform circular motion, meron tayong natawag na radial acceleration. So ibig sabihin ito ay ka-accelerate. Now, sabi natin about the radial acceleration, it is always pointing towards the center. So, always ituturo niya to, no? Always to the center of the circle. So, ganyan yung itsura ng ating FBD. So, now we draw or we create our summation of forces equation. Start tayo by X. So, ito yung ating Y-axis. Ito yung ating X-axis. So, anong forces natin sa X natin? Ang force natin sa X ay itong, wait, let me just rewrite that. Okay. So, kung papansin ninyo si F natin, meron siyang Fi hat and meron siyang Fj hat ulit. No? So, ganun din dito. So, ibig sabihin sa X natin, meron tayong negative Fi hat or Fx, kayo bahala. Negative Fi hat. And as you can see, sa X natin, meron tayong A-rad, no? Kasi to the center nga yung A-rad natin. So, this is equal to MA-rad, but negative kasi nga negative direction si A-rad. Now, for our Fy, meron kang, ano bang force mo sa Y? Yung Fj hat mo. So, Fj hat plus negative weight. Nag-accelerate ba siya sa Y? Hindi, wala, di ba? Kasi yung A-rad mo to the center lang. So, nandito lang si A-rad natin plus. So, Fj plus negative weight is simply equal to 0. So, kung titingnan ulit natin ito, yun siya. If this is beta, then this must also be beta. So, ito yung F, ito yung Fi hat, ito yung Fj hat. So, yung Fi hat natin, relative to beta is opposite. So, this is F sine beta. And yung Fj hat natin is F cosine beta. So, I'll rewrite my equation, itong Fx natin, to Fi is F sine beta equal to MA rad. So, tinanggal ko na yung negative class kasi mag-cancel out naman yan. And then for Y naman, this is simply F cosine beta is equal to weight. Okay, is equal to weight. Now, ang binigay lang sa atin, ang given lang class ay yung beta, tapos yung length. Ito yung mga binigay niya. Length, beta. Wala na silang ibang binigay. And these are the kind of problems na walang value, arbitrary lang siya lahat, no? So, wala kayong ipa-plug in. Puro ganito lang. So, F sin beta is equal to MA rad and ang hinahanap natin ay si F. Which means that F is equal to MA rad over sin beta. Ang problema natin, binigay ba sa atin kung ano ang A-rad? Hindi, di ba? We don't know what A-rad is. And at the same time, class, hindi binigay sa atin, binigay sa atin si beta, so okay lang yan. So, ang gagawin natin ay hahanap tayo ng expression ng A-rad. Ano ba naaalala natin about A-rad? Ang A-rad natin is 4 pi squared r over t squared, or ang A-rad natin is v squared over r. So, alin dito yung gagamitin kaya natin? Given ba si V? Hindi, di ba? Hindi given si V dito. Nandito siya sa drawing pero walang binigay na value. Now, given ba si R. Hindi rin, pati si period, hindi rin given. Pero, kung makikita nyo, yung R natin, may relationship siya sa length. Take note, binigyan nyo length sa atin. So, kung titignan nyo, ganito yung drawing, di ba? Ito yung vertical, ito yung R, ito yung L, and ito yung beta, di ba? So, kung mapapansin nyo, may relationship si R, si beta, at si length. So, si R is opposite the radius. So, R is actually L sine beta. No, si opposite siya, L yung hypotenuse. So, ibig sabihin, pwede kong gamitin itong equation na to. No, pwede ko siyang gamitin. So, magkakaroon ako ngayon ng M over sine beta. Yung A rad ko ay 4 pi squared R over T squared. Eh, ano ba yung R ko? This is simply M 4 pi squared times L sine, L sine beta over T squared sine, sine beta. So, pwede ko na ito i-cancel. And therefore, my force is equal to 4 pi squared M over T squared. Wait, parang may mali. Kasi hindi ko rin pala alam yung T. So, saan ko kukuhanin yung T? Where do we find T? So, hindi ko pala pwedeng gamitin pala parehas, no? Wait lang. Oh, wait. I think, sige, balik tayo. Ulitin ko lang itong part. Ulitin ko lang class, no? So, balikan lang natin. Ulit. So, nag-FBD ako ng BAM. And then, ang FBD ko ay meron ako ng weight, meron ako ng tension force, and alam ko na yung A-rad ko ay directed sa center, no? So, sabi din natin kanina na si F natin is meron siyang Fx at meron siyang Fy. Okay? And then ito ay beta. Ay, baliktad. F. And then yung beta natin is nasa loob. So, ito yung beta. Oh, no, sorry. Tama nga. So, ito yung F. Ito yung beta. Okay, so ganyan, di ba? And then, nag-create tayo ng summation of forces. Summation of force along x mo is negative Fx is equal to MA rad. And si Fy naman natin is Fy plus negative W is equal to 0. Wala tayong acceleration sa y. So, same pa rin kanina. Pero, tapos, ang ginawa natin, nire-write natin sila, di ba? Si Fx naging so may negative din pala dito kasi A rad is to the left din. So, si Fx natin kanina, sabi natin, so ganito yung itsura. This is F, Fx, Fy. So, kung ito is beta, ibig sabihin ito rin ay beta. So, si Fx natin is sine, si Fy natin ay cosine. So, as kanina, so this is F sine beta is equal to MA rad. Pero, okay, yan. Tapos ito is F cos theta is equal to weight. Pero yung problema pala natin dito, class, kung ito yung gagamitin ko para hanapin si force, ang problema ko ay si A-rad kasi hindi ko pwedeng gamitin yung V squared over R kanina or yung 4 pi squared blah blah blah. So try na lang natin palang gamitin si pi, yun lang pala. Y na lang pala yung gamitin. So F cosine theta is weight. So F ay cosine beta, sorry. F is basically mg over cosine beta. Okay? So given yung mass with a mass m, with a length L, and with angle beta. Ito lang yung given sa atin, mass, length, and beta. So, kaya natin i-solve kung binigyan tayo ng mass at binigyan tayo ng beta at alam natin yung G. So, ito na yung F natin. Now, yung next is yung period time T. Dito pala natin gagamitin si X, okay? So, from X, meron akong F sin beta is equal to MA rad. Dito na magagamit ko na yung A rad, which is 4 pi squared R over T squared. Okay, so sorry class, no? Dapat hindi ko pala siya ginamit kanina. Itong Fy pala muna. So I have F sin beta is equal to M times 4 pi squared R over T squared. Now, you need to take note, this T yung hinahanap natin. So, we isolate this, cross multiply. I have T squared is equal to 4 pi squared R M over F sin beta. Ngayon, alam na natin yung F kanina, di ba? F is ito, mg cos beta. So, get the square root muna. So, I have T is equal to 2 pi. Ilabas ko lang yung 2 pi. R over M over ang F natin is mg over cos beta sin beta. So, cancel out yung M. And so, I have T is equal to 2 pi square root of sine over cosine is tangent, di ba? So, tama ba ako? So, you have R over, wag ko naman na i-tangent, R over G sine beta over cosine beta. Okay, and then pwede natin itong iakyat sa taas, diba? Kasi parang ang structure niya ay R divided by G sine beta over cos beta. So, parang magkakaroon ka ng R times cos beta, babalik na rin mo to, over G sine beta. So, pwede ko sulat to na R cos beta over G sine beta. Ngayon, hindi given yung R sa ating class. Pero napakita ko na kanina na yung R natin, pinakita ko na, di ba? That R is simply L sine beta. So, balikan nyo na. So, we can rewrite this therefore as 2 pi square root of L sine beta cos beta over G sine beta. So, cancel. Meron akong T is equal to 2 pi square root of L cosine beta over G. So, yan yung ating final na sagot. So, ibig sabihin, pag binigyan ka ng length class, binigyan ka na ng beta, makukuha na yung sagot natin dito. Okay, last example. So, for a car traveling at a certain speed, it is possible to bank a curve at just the right angle so that no friction at all is needed to maintain the car's turning radius. Then a car can safely run the curve even on wet ice. Your engineering firm plans to rebuild the curve so that a car that is moving at a chosen speed can safely make the turn even with no friction. At what angle beta should the curve be banked? Assume that the radius of the curvature is 230 and the speed of the object is 250 meter per second. So, ito yung mga tinatawag natin banking curve, no? Lalo na pag paakyat kayo sa mga bundok, yung mga pa-ganyan, no? Sobrang pa-inward or yung ikot. So, ang pinapahanap sa atin dito, ano daw yung angle beta ng pagkaka-curve ng bank para safe na makaikot yung car even with no friction. So, lalo na kapag siguro sa ibang bansa yung setting nito, lalo na kung ice, no? May ice yung daan. Or pwede naman sa Pilipinas, lalo na pagbasa yung daan, no? Siyempre, pagbasa yung daan, lesser yung friction. So, dito, gawa mo na ulit yung FBD. So, dito ko na siya ipipick up. Ito yung car. And ito yung weight. Okay? And then, yung curve natin is pa ganyan. So, ibig sabihin yung normal force mo ay pa ganyan din. Perpendicular. Okay? And then, it has constant speed, but it's moving about a circular path, no? It's moving about a circular path. So, ibig sabihin, kailangan natin dito ng irad. Kailangan natin dito ng irad. So, yung irad mo is to the center ulit. So, ito. Okay. So, wala na tayong ibang force. So, again, isa-set ko ito. Pipili tayo ng perpendicular. Yung irad nyo pas pa ganyan. Hindi siya perpendicular kay normal. So, perpendicular si normal sa surface niya. Di ba? Ito yung surface niya. Pero, may dalawang force ka. Perpendicular, hindi pala force. May weight ka at saka isang element, irad, na perpendicular. So, ang gagawin ko dito class, ipa-follow ko na ito yung y-axis ko and ito pa rin yung x-axis ko. Okay, so ganyan yung gagawin natin. Therefore, yung normal ninyo, meron siyang component along x and component along y. So, erase ko lang. So, ito yung x. Okay. So, irad again is dito lang din for x. So, irad ito. Irad. Okay. Na si normal natin, may component siya sa x and may component siya sa y. So, yung magiging equation natin, summation of force along y, which is n plus negative w, ny pala, plus negative w, walang acceleration sa y, so this is simply equal to 0. And yung x natin is simply nx, no? So may nx tayo, positive, is equal to, may acceleration tayo sa x, no? Itong a-rad natin. So this is equal to positive ma rad. Okay? So if this is beta, then this must also be beta, no? Vertical angles. So beta yan, beta rin ito. So ibig sabihin class, pag dinrawing natin yan, ito si n, ito si nx, ito si ny, di ba? And then ito si beta. And therefore, yung nx natin class is adjacent. So this is n cosine beta, and si ny natin is n sine beta. Okay, so fx, therefore, is simply n cosine beta is equal to ma rad. Okay? May binigay na speed sa atin, may binigay na radius. So, ibig sabihin, yung cosine beta ko is equal to ma rad over n. Alam ba natin yung mass? Hindi. Alam ba natin yung irad? Hindi. Alam ba natin yung normal? Hindi rin. So, ano alam natin? Okay, so anyway, wala tayong alam dito. But we do know that we can work with irad first, no? Yung irad natin, since ang given sa'yo ay v, tsaka r, pwede kong gamitin yung v squared over r, di ba? So, irad is v squared over r. So, pwede ko itong i-rewrite as cosine beta is mv squared over r times the normal. Okay, napunta tayo dito. Kasi alam ko na yung V, alam ko na yung R. Ang problema ko yung mass tsaka yung normal. Ito merong normal element, so pwede kong gamitin. Ang normal ko dito is n sine beta equal to weight. So, ibig sabihin n is equal to weight over sine beta. Pwede ko siyang gamitin dito. Cosine beta is equal to mv squared over r times weight over sine beta. Okay, so i-pause nyo na lang kung masyado kayo nadadalian, no? Nabibilisan pala. So, yung n, palitan natin ng weight over sine beta. Then, katulad ng ginawa natin kanina sa nakarang example, pwede ko itong itaas. No, property siya ng ano. So, magkakaroon ako ng cosine beta is equal to mv squared sine beta over r. Ang weight ko is mg. Diba? Weight is mg. So, cancel out, cancel out. And then, ayoko naman ng beta dito, lipat ko siya sa kabila. Kasi nga, yung beta yung hinahanap natin. So, I'm going to multiply again both sides by 1 over sine beta. Ano yung makukuha? So, cos over sine is, ano cos over sine? Baliktad ng tan, di ba? So, 1 over tan. Okay, mahirap. Ayoko. Ang gawin na lang natin, ilipat ko lahat tong v squared rg sa kabila para sine over cos ang yung makuha ko. So, lipat ko to. Magiging r cos beta over v squared ay rg pala. r cos beta over v squared is equal to sine beta. Tapos saka ako mag-divide ng cos beta. Ayan. Parang matira sa akin is tangent beta is equal to g times r over v squared. And beta therefore is simply tan inverse of gr over v squared. So plug and play na lang to, class. G is 9.8 times 230 over 25. Huh? 74.5? Parang mali naman yun. Wait lang. Kasi diba, yung banking mo, 74.5, ang laki, parang yung makakaganda ba dun sa sasakyan? Parang hindi, it doesn't make sense, diba, sa rate lang class. Tama ba yun? Tan inverse 9.8 times 230 over 74.5 talaga. So, paano ko napagay lang sa kasi parang unrealistic, no? Anyway, sama naman to. V squared GR. Oh, I think it should mali yata ako ng pagka-settle mga be. So, hindi pala dapat ito yung beta. Ito yung beta. Okay? Kasi kung ano yung angle, yeah, paano ko ba ito explain? Itong part na to, diba ito yung beta ng yung angle beta ng curve niya from the horizontal, no? So, kung ano yung curve niya from the horizontal, ibig sabihin, so kung from the horizontal, umangat siya ng 50, ay, ng 55 daw, ng some degree, ng beta degree. Ibig sabihin, yung y mo, gumalaw din ng some beta degree. So, dapat ito pala yung beta. So, ibig sabihin, yung nakuha natin ay itong part na to, which is 90 minus beta. So, ito yung 90 minus beta. So, ibig sabihin, ang beta, so same process lang klase, nagkaroon lang ng, pangalanan ko na lang ito na iba. Okay, so pangalanan, kasi kanina, ito yung pinangalanan kong beta. Sige, so ang tanong na lang ay, at what angle alpha? Ito na lang si alpha, at alpha na lang din to. So, ang alpha natin, sabihin na lang natin is equal to 90 minus beta. So, at what angle alpha? So, ang alpha natin dito ay 90 minus 74. So, which means that alpha, okay, yung final na sagot natin is therefore 15.5 degrees. Okay? So, I want you to try this one class, pero gamitin nyo na, ang gagamitin nyo na ay iayusin nyo, no? Magbabaliktad kasi yung sine at cosine. Kasi nangyari dito, ito yung sinet ko na beta, mali ako ng understanding. Kala ko equal sila, hindi pala dapat. No? Kasi pag nag-beta din to, ito pala dapat, ganito pala yung vertical angle, mali ako. So, itry nyo isolve to na yung tamang beta na isa-set nyo. No? So, ito yung tamang beta, yung pinakamalapit sa north. So, try to solve this and see if tama ba na 15.5 yung makukuha. I think that's our last example. So, please review, no? Ito, lalo na itong part na to, ng Bob, no? And then, this one as well, no? So, paki-check na lang. And also, this one, Atwood's machine, ito yung isa sa pinaka-importante. So, that's it. Thank you.